All right. Let's think about what goes on in this calculation. So first thing that goes on is we convert each of the lists to standard units. If I add the same number, suppose that my yardstick is 2 inches too short. Okay, so every height measurement is off by 2 inches. Is that going to change the value of the correlation coefficient if I made that kind of measurement error? No. Okay, because all that's going to do, it's going to shift every value by 2 inches. It's going to shift the mean by 2 inches as well. And when I convert to standard units, I'm subtracting the mean. So I'm subtracting off exactly that difference. It's going to just cancel out. Okay. If I measured people's height in centimeters instead of measuring their height in inches, would that change the value of the correlation coefficient? Okay. The relationship between them is that a centimeter is 2.54 inches. Sorry, other way around. An inch is 2.54 centimeters, right? So I'd be multiplying every measurement by 2.54. When I convert to standard units, what's going to happen to the standard deviation? Standard deviation is going to be bigger by a factor of 2.54. So when I divide by that, it's just going to cancel that factor of 2.54, and I'm going to get exactly the same values in standard units. So converting to standard units, because it subtracts the mean, because it divides by the standard deviation, any affine transformation I make to one variable is going to go away. Okay? So one of the reasons for going to standard units, what it means to be standard, is that it somehow removed any affine transformation. It's putting things on a scale where after you transform things to standard units, anybody want to guess what the average of those numbers is? I have a guess of 0. I like that guess. Yeah, after you convert to standard units, the mean of the new list is 0. And the standard deviation of the new list is 1. Okay, so no matter what units you started with, after you do the transformation, what you get has mean 0 and standard deviation 1. Can we prove that that would be the case? Let's take just a few seconds to do some math for grins. Okay, so we've got some list of numbers, x1, x2, up onto xn. Okay, and now what we're going to do, let's let, just to be fancy, we're going to call the mean x bar is 1 over n times the sum from j equals 1 to n of xj. Okay, that's the mean. Okay. And then we've got the, and I'm just going to call, what do I want to use for this symbol? I don't really want to use S. I'll use S. OK. S is equal to 1 over n OK, so that's the RMS of the deviations from the mean. I take each element of the list. From it, I subtract the mean. That's the list of deviations from the mean. And then I average those deviations from the mean. I get the mean of the squares. So I square them, add them up, divide by how many there are, and then I take the square root of the result. So that's the RMS of the deviations from the mean. Okay? And now, question is, if I take this original list and I convert it to standard units by subtracting x bar from each element and dividing the result by s, what is the mean? What are the mean and the standard deviation of the result? So let's do the mean, because that'll be fairly quick and painless. So I've got my new list looks like x1 minus x bar over s, x2 minus x bar over s, so forth onto xn minus x bar over s. Okay, I've got n values. And now want to ask, what's the mean of that list? Well, 1 over n times the sum from j equals 1 to n of xj minus x bar over s, right? That's what we're trying to find. Okay, so I can pull the 1 over s out front, right? That's just a constant. So that might as well be 1 over s times that. This is a sum, right? I can break the sum into two pieces. This is like 1 over s, 1 over n times the sum j equals 1 to n xj minus the sum from j equals 1 to n x bar, right? The summand here, this thing inside, doesn't depend on n, right? I'm just adding x bar to itself n times. What happens if I add x bar to itself n times? I get n times x bar, right? Okay, so this sum is just n times x bar. So far, so good? Okay. Now, I'm going to distribute the 1 over n. I've got 1 over s times 1 over n sum j equals 1 to n xj minus 1 over n times x bar. So that's just x bar, right? This is x bar, right? That's the definition of the mean. So I don't know if you can't see this. This doesn't go up, it goes sideways. Can you guys see it? Okay, so this is 1 over s times x bar minus x bar. So it's 0. Is that all right? Yeah. Okay. You will not be expected to reproduce this. But the point is that if you take a list and convert it to standard units, the mean of the new list is 0. And you can take my word for it that the standard deviation of the new list is 1. Or you can work it out for yourself. Or you can look at the footnotes because it's probably buried in there somewhere as well. All right, so because the